Hello and welcome back. So we have seen how to use the stochastic gradient descent regressor, SGD regressor, and how to play with the hyperparameter alpha and find the best model, right? But we had a concern. We don't know whether the 0.01 is the best hyperparameter or not. Maybe there is a best hyperparameter between 0.01 and 0.02, right? So if you want to find that best hyperparameter, you may have to play with many different eta zeros and many iterations and other hyperparameters also. This is called as hyperparameter tuning. Generally, when we looked at the complete end-to-end process, we have seen that when model is working well on the train set, you will try to see, you will try to do fine tuning, or when the model is not working uh, well on the train set or overfitting on the train set, you may do fine tuning, right? This is actually called as fine tuning, right? Whatever we are doing on a model, kind of SGD regressor, the hyperparameter tuning is called as one kind of fine tuning. We can use grid sets CV class to select best hyperparameters, or in other words, we are actually choosing the best model, best SGD model with appropriate hyperparameters. You can build 100 models with same SGD regressor with different hyperparameters. Out of all these 100 different models, you need to choose the best. We have already seen how to do that with grid set CV when we did the polynomial regression. Right? We did one degree polynomial, 2 degree polynomial, 3 degree polynomial. We used pipelines and the grid set CV both concepts there. We are going to do that again here. So here, when you are applying SGD regressor, you have to do standard scaling. And we know that the third degree polynomial is the best. Or you can actually give 1, 2, 3, 4 also. Right? All the degrees also you can pass. So you need to convert your data set into polynomial data set and then apply standard scaling and then apply your SGD regressor. Using that model you need to predict. That can be achieved with the grid set CV. So in the grid set CV we have passed the pipeline and the param grid. What pipeline will do? Pipeline is a sequence of steps, data processing steps, right? So polynomial features is the first step, standard scaling is the second step, and then building SGD regressor model is the third step. Okay, it is going to do, the pipeline is going to do them in sequence. It converts your whatever x you passed into polynomial and then apply standard scaling. Now whatever the polynomial data will be passed to standard scaling, and the standard scaling's outcome is going to be passed to the SGD regressor, and the model is going to be present in the grid search's best estimate. Okay, so when you passed polynomial features 3 and eta 0 np.linspace, right? Linspace method will give you numbers between the range, right? 0.01 to 0.001. I want 20 numbers, so it's going to have a numpy array with numbers between 0.01 and 0.001, 20 numbers. And then I gave max iterations as 300 and 400. So it is going to build 1 into 20 into 2. 40 models it's going to build. On top of these 40 models, you know that the cross validation I gave 20. 40 into 20, 800 models it's going to build. So it is going to get 20 pairs of cross validation and train errors, out of which it will choose the best model with higher accuracy, the R square score, because the scoring method we have chosen is R2, and then which is giving the closest cross validation and train error. Out of 20 pairs, out of 40 pairs, right? Why 40? Here 20 learning rate numbers and 2 iterations, right? 300 and 400. So it's going to take 3 as the third degree polynomial. It's going to take 0.01 as alpha, the learning rate, and then 300 iterations. 300 iterations it will do. Again 3, 0.01, 300 iterations. Like that, it's going to build 40 models. 20 into 2 into 1. 40 models it's going to build. And out of 40 pairs, right, when it does the cross validation on the first model, it's going to take 20 pairs, so one pair, and then the like that it's going to take 40 pairs, and out of which it will choose the best. So it actually chose the best estimator with the third degree, and eta 0 is 0.003. And here we used 0.01 on a simple linear regression, but it's on a third degree polynomial, right? So it chose the best model. On the best model, we made predictions and did calculations. We did the accuracy measures. We were at 92% and 91%. So I kind of did a little bit of hazy fine tuning here. You can play with the model and you'll get more accuracy. So that's about fine tuning a model using pipeline and grid search CV. In order to get more hold on this concept, you need to practice a lot. I hope you will do that. Thank you.